Okay, good morning once again. So we'll be seeing today two more forces, but before that, just a recap of what we did yesterday. We saw about an important contact force, which is tension in a string, and I took some examples where I explained how to take tension. I hope it was clear. And we also saw that if we take an ideal string, good morning once again. If we take an ideal string means when a string is almost massless, then in that case what we have to remember about tension, the tension will be same at all points in an ideal string. So if you have a single ideal string, the tension will be same at all the points, right? Why is it so? Why will the tension be same at all points? Because you can say that net force is equals to mass into acceleration, right? But if the string is ideal, means its mass is negligible or 0, so m into a will become 0. So net force should become 0. That means tension at every point should be same, because if the tensions are different, then there will be a case of, you can say, unbalanced forces. So when it is an ideal string, we have to remember that tension is same at all points. So after what examples we saw yesterday, we will take quickly two examples more to find the tension. Suppose we have blocks as given and you are applying some force. Let's take, we are applying a force, and here we are seeing a string, an ideal one. If nothing is mentioned, means we will take it as ideal. Okay. Now F is, suppose I am applying a force of 20 Newton and this one is 3 kg and this one is 2 kg. Clear? So what do you think? Will this system of blocks stay stationary or will they move? Reply fast. Will the system, obviously yes, correct, it will move. Now when we talk about the tension, I said tension is always a pulling force. Tension is always a pulling force. So when I will show tension, now see this string, at every point on the string tension should be same. Every point on the string tension should be same. Now if I take this 3 kg block, you see what force is acting on the right side? It is 20 Newton. What force will act on the left side? On the left side 3 kg is connected to the string. 3 kg is connected to the string. So which force will act on 3 kg? It is the tension. Again telling, on right side 20 Newton force is acting. So which force will act on the left? It is connected to string, so tension. Now tension is a pulling force. So on 3 kg, what should be the direction I should show for tension? Reply fast, reply fast. What should be the direction of tension on 3 kg? Remember, tension is a pulling force. You can pull anything by a string or a rope. You cannot push, you can pull. So string will exert a tension on the 3 kg block in which direction? Yes, correct, left. Simple thing. Just think that you are the string. What will you do to 3 kg? Pull. Pull means which side? See my hand movement, left. That's it. That is the direction of tension. Now same, this string is same everywhere. So now come to 2 kg block. Is the force 20 Newton applied on 2 kg? Answer is no. 20 Newton force was applied on 3 kg, not on 2 kg. So 2 kg will be connected or will be pulled only by the string. 2 kg is connected only by the string. So again, what is the role of string? String will always pull you, not push you. So where will the string pull the 2 kg? Just imagine that you are the string. In every question, if you confuse, just you imagine that you are the string and you have to pull. So which direction will you pull the 2 kg block? correct? It will be right, the same tension towards right. Now the final thing, let me ask you one final thing. These two blocks, will they have the same acceleration or unequal acceleration? Means will they move together or will they move differently? Just by common sense you can say, will they move together or will they move differently? They will move, yes, correct, they will move with the same acceleration. So both acceleration will be same. So now when any body accelerates, which law are we going to use? Which law are we going to use for body accelerating? We will be using which law? When a body or a particle or a system, correct? We will be using which law? We will be using the second law. Very good. So by second law, what I can write on this 3 kg net force, where is the acceleration towards right? I will use net force is equals to mass into acceleration. See the direction of acceleration, it is towards right. So net force should also be towards right. What is the net force towards right? 20 right, T left. So net force, can I write 20 minus T? And this will be equal to mass is 3 kg, acceleration is A. Similarly, if I see here also I will use net force is equals to mass into acceleration. Acceleration is towards right. Which is the net force towards right? Only T. So T will be equal to 2A. So if T is equals to 2A, can I substitute over here? So from here 20 will be equal to 3A plus T. And what is the value of T? 2A. So we get acceleration as 20 by 5, that is 4 meter per second square. And once you get the acceleration as 4, so tension, which we have already received answer earlier, very good. But since I am explaining, I need to explain for every student. So tension value is how much? 8 Newton. Is it clear to everyone? Just by basic equations and knowing the concept properly, that you have to see whether the force is a pulling force or a pushing force. You will easily get the answer. Clear? Okay. We will see one more example where in place of blocks connected directly, we will use pulley also. No problem, you can understand. You all know that in villages still people take out water or draw water from a well using a pulley, and even in our modern cities everywhere we have, even in towns also we have gyms. So in gyms also you have weights being pulled with the help of cables and pulleys. So you all are aware of what a pulley is. It is a disc over which a cable or a rope or a string can go. Now here we are taking this situation where we have two blocks, and this is suppose the heavier block, this is the lighter block. I am taking capital M, this is heavier block, right side. So they are going over a pulley with the help of a string. Now quickly tell me that in which direction the bodies will move. Capital M will go up or capital M will come down? And will the bodies move together or differently? Correct, capital M will move down. And will the bodies move differently or together? One answer I am getting correct, but one answer many students are answering wrong. They won't move differently. They are moving together. Their directions of acceleration can be different, but they are moving together. As much capital M will come down, can I say small m will go that much only upwards? Understood? If you consider the case of a person drawing water from a well with the help of a rope, as much you will pull the rope down, that much the bucket will lift up. So they will move together, na? So you can say that it will accelerate down due to its weight being more, and this will accelerate up. Now talking about the tension. Again you see the string is same everywhere. If string is same everywhere, what I said in the beginning, tension in an ideal string is same at all points. Did I say so? So I will say whatever is the tension over here, that will be the tension here also. Whatever is the tension here, that will be here also. Now the direction of tension. What I told you, if you forget the direction of tension, assume that you are the string and try to pull the objects, you will get the direction of tension. Now if you are the string, which direction will you pull the small m mass? You are string, where are you pulling small m? If you are the string, where will you pull small m? Venu, it's wrong. How will you pull it down? If you are the string, will you pull down or will you pull up? String is up. String is above the mass. So where will you pull it? Up. String is above capital M. Where will it pull it? It is for both the blocks. String is above the blocks. So tension will be upwards. Tension will be upwards. Now if I ask you the same string, where will it pull the pulley? The same string, where will it pull the pulley? Yes, the pulley will be pulled down because string is below the pulley. So I will say the same tension will pull the pulley down. Okay. Now if I have to find the acceleration and tensions, how we will do? Again just like this, one by one I will draw the blocks. One is small m. What force can you see is acting on small m upwards? It is capital T. What force is acting downwards? Every body I said it will be pulled down by gravity, mg. Where is it going? Upwards, A. So what I will write equation just by second law, as I told, T minus mg is the net force which is pulling it up. T minus mg is the net force which is pulling it up. This will be equal to mass into acceleration by second law. Similarly, if I see capital M, what force is pulling it up? T. What weight? Mg down. Where is it coming? Downwards. So what should be the direction of net force? Downwards. How much is the net force downwards? Mg minus T is the net force downwards, and by second law, mass into acceleration. So this is the net force on capital M. This is the net force on small m. So you have got two equations and two unknowns, first and two. So once we solve these two equations, you will get the value of tension. Understood? So if you substitute the value of, or you add first and second equation, you will get acceleration, then substitute, you will get the value of tension. Clear? Now, once we have this, let me just tell you what I have drawn over here. Some of you may be confused over here, that what about the pulley? Now if you see the pulley, I am drawing the forces on the pulley also. You can see the same string is trying to pull the pulley down from both sides with what force? Tension. Two tensions are pulling it down. But if these two are pulling it down, it should have fallen. Why is it not falling? Because it is attached to the ceiling. There is a clamp over here which is attaching the pulley to the ceiling. So that means it is not falling down because the clamp force, it will be pulling it up. The clamp force is pulling it up. So if you see the pulley is not falling down, even there is two tension acting, because there is a clamp which is pulling it up and sticking it to the ceiling. Otherwise it would have fallen down. And as far as the values are concerned, that what is the tension and acceleration, you very well know from equation first and second we can solve. From first equation and second equation, when you solve, you will get acceleration as m minus m into g by m plus m. You know very well how to solve simultaneous equations. and T you will get as 2 mmg by m plus m. So you get the tension and you get the acceleration by solving these two equations. Both equations are second law equations. Clear? Please take a screenshot of the same, what all points I told, see the important points, note them fast so that we move on to our next important forces, contact forces. So we are talking about contact forces. We saw tension, which is what we call as tension, and it is always what you will remember, it is a pulling force. Clear? And these forces, contact forces, I told yesterday, they are electromagnetic, and second thing, they are not always present. They are means they develop in a body whenever some external agency tries to bring any change, right? So one change you saw, next you will see next force which we will be talking about is what we call as normal reaction, and we will be denoting this force as N. Normal reaction, which will be denoted as N. Now how it is different from tension? It is always a pushing force. Now tension was a pull, normal reaction is always a pushing force. Clear? When will it act? It will not be acting always. Many students or most of the students think that any body is in contact with some other body, so they will say normal reaction will. No, normal reaction, this also develops between surfaces or objects in contact when they get pushed or pressed against each other due to some external agent or cause. So if by any chance you see that two objects or two surfaces get pushed or pressed against each other, then only this force will develop. I am again stressing on the word, remember it's not always present, develops. Understood? So some external agency would be trying to push the two surfaces or objects against each other. One more important thing about normal reaction is its direction. As I told, it is a pushing force, but in which direction it acts? It is always perpendicular to the surfaces in contact. It should always be perpendicular to the surfaces in contact. So you have to see the surface in contact or line of contact, it will be always perpendicular to the surface of contact. Now if I see, for example, you will understand. First example, suppose I have a block of mass m kept on ground, and I said every real force will obey Newton's third law, every force will obey Newton's third law. So what we have is, we will say that forces are equal and opposite. That thing should be clear. I will take by example. Now I told yesterday that mg is not exerted by a body on other body. Mg is always exerted by earth on a body due to gravity, right? What you exert is a contact force. When two bodies are in contact, you only exert contact force. So here when I see capital M, first of all, let me think whether normal reaction will come or not. You can see that ground is the surface of contact. So this line which you can see in the diagram, this is your surface of contact. Let's call it as SOC. This line you can see is SOC. Now one by one, what force will Earth exert on this block due to gravity? The answer is mg. Where does mg act? I told yesterday, downwards. Now can you see that due to mg, this block is getting pressed on the ground? Yes, this block is getting pressed on the ground. So as the block gets pressed on the ground will feel the pressure. So where will ground exert force on the block? Is the block flying away or the block is there only? Is the block flying away or is it there only? It is there only. That means the forces should be balanced. So when it is getting pressed on the ground due to mg, so the ground will push it up. So since the two surfaces are getting pressed due to an external force mg, so it is getting pressed down, so the ground pushes it up. So ground will push it up. This is the normal reaction which is exerted by ground, not earth. We will say by ground, on the surface on which it is lying. Now we can say by Newton's first law, because it is not moving, it is not having any acceleration. So by Newton's first law, can I say upward force should balance downward force? Upward force should balance downward force. But if you see the same force, if I see the ground, now I ask you how much force, or I will not ask how much force, which force will the block exert on ground? Just tell me the force name which the block will exert on the ground. I am asking just the name. Please don't tell values or anything, just tell the name of the force that the block will exert on ground. Mini, you are totally wrong. Krishna, wrong. All are giving wrong answers except for Subhashini, yes. All others are giving wrong answers. All are giving wrong answers. I think again you are not following the class. Some of you are more interested in talking to each other. Joshua, correct answer. The answer is third law, normal reaction. Did I say yesterday every force has equal and opposite reaction? So if the ground is exerting normal on the block, then the block will also return the same force, na? Normal will also, block will also exert the same force, that is normal reaction. So N by the block on the ground is exerted. On the block, two forces are exerted. What are the two forces? One is mg. This is exerted, we know, by earth. I am writing again. Due to a property or phenomenon which is known as gravity. So gravity, due to gravity, mg is exerted on the block and normal by the ground is exerted upwards. Which force will now the block exert on the ground? Normal. It will return the same what you are getting. So the return gift is same as the gift being accepted over here. Okay? Understood? So you won't say any other force except for the force that the other surface is exerting on first surface. Only the direction gets reversed. And you can see the direction of normal is taken perpendicular to the surface. This is the surface in contact between the block and the ground. So the force is always perpendicular to the surface. Is it clear to all of you? Okay. Shall we go for other example first? Okay, fine. Now here comes the next situation and I would like to hear answers First you have to check whether it is moving or it is static or all. This you can see is ground. This you can see is a wall, and here we have a block. I want the values of what is the normal reaction by the wall, so on the block I want the two normal reactions. Let's see, you can give your answers separated by comma. First normal reaction by wall on the block, and second normal reaction by ground on the block. Next situation we are having, so the next situation we have, again we have to say on the block what will be the normal reaction by the wall and normal reaction by the ground. Okay, very good. One or two correct answers. Ratna, correct answer. Soumya, correct answer. Mini, correct answer. I have asked you to reply, not to re-ask. That is my job, I will tell. Sushant, yes, correct answer. Now see quickly. Here, if I ask you just the basic thing, is the block getting pushed by any external agency or by any reason? Is it getting pushed against the wall? Is it getting pushed against the wall? Reply me fast, yes or no. Is it getting pushed against the wall by any other force? No. So if it is not getting pushed, will normal reaction develop by the wall? Answer is no. So I will say normal reaction by wall is equals to 0. Okay, you can say that horizontally it is not pushed against the wall. Not getting pressed. So if you just stand touching a wall, it does not mean it will exert normal reaction. Remember from now onwards. Getting pressed against the wall. But if you see vertically, due to its weight, just like the previous example, due to its weight, it is getting pressed downwards. So if it is getting pressed downwards, so obviously the ground will exert a normal reaction upwards. So this force is balancing mg. So we will say normal reaction by ground is mg. But in second case, if you see the diagram again, from right side, the person is applying a force F0. So here it is getting pressed. Here it is getting pressed and mg is acting downwards. So it is getting pressed on the ground also and it is getting pressed towards the wall also. Now, will it horizontally accelerate? Answer is no. Will it vertically accelerate? Answer is no. So when it is getting pressed, normal reaction from wall will also come, pushing force, and normal reaction from ground will also come. Both are pushing forces. Normal reaction is always a pushing force. Now we can say horizontal acceleration is 0. Horizontally you are not moving, you are stuck to the wall. That means the forces should balance. Normal reaction by the wall is balancing F0. and vertically also this block is not flying away anywhere. Acceleration vertically is also 0. So normal reaction exerted by the ground is balancing mg. So we say by force balancing the answer will be n wall is F0 and n ground is mg. Is it clear to all of you? Are the two situations clear to all of you? Okay. Fine. One more example we'll quickly see, where suppose here we have a vehicle moving on the road with some acceleration a0. This is a truck, and here we have a box whose mass is m. Now as the truck will move forward, so you all know about inertia, so will this box slide to the right or will it try to move towards left? Tell fast. As the truck is accelerating forward, so we all know about inertia, so will it go right or left? Obviously towards left, because it will try not to move, so it will go left, correct? So in doing so, by inertia, will it get pressed against the backside wall of the truck or not? Will it get pressed against the backside wall of the truck or not? Yes? Okay. So this box gets pressed against back of the truck due to inertia. So if it gets pressed, will it move differently than the truck or will it move with the truck? Will it move differently than the truck or will it move with the truck? With the truck, because it has stuck. Due to inertia it has stuck. Harsha, you are totally wrong. Chakri, you are also wrong. Think, okay. Instead of thinking about other things, focus on the class, you will understand why you are wrong. It will move with the truck, it has got pressed. When two things get pressed together, suppose my two hands, I press them together. If I move one hand, both are moving together or differently? They are moving together. So they are moving together. So if I stand from the ground and look at the box, what will be its acceleration? Tell me. What should be its acceleration? Yes, Vivek, one wheel is halved. Beta, I have just hidden the wheel. Okay, half of the wheel is inside the truck. You won't be able to see. If you actually go and enter in the digital board and go and see from backside, then you will be able to see the whole tire. We are not focusing on the construction of the tire. We are focusing on the acceleration. Correct. Now we are getting correct answers. The acceleration will be a0 only. So when I see this block or box seen from ground, I will say that this block or box is moving horizontally. Now what all forces are acting on this? You will say one force is mg, one force is normal by the floor of the truck upwards, but it is accelerating. Can any body have acceleration without a force? Please reply fast. Can a body have acceleration without force? No. Now if it is accelerating rightwards, means there should be some force. What is that force? Who is pushing this box forward? Let me hear fastly. Which force is pushing this box forward? Which force is pushing so that giving it acceleration? Without, yes, the truck is pushing it. So that will be the normal reaction by the wall of the truck. Since it is getting pressed, I said whenever you push it, Weber pseudo force, don't go for such heavy terms right now. There is nothing to be used or called pseudo force in this case. I am seeing from ground. I think you have slightly from somewhere caught hold of this word pseudo. Don't get confused right now. You will later on learn to know more about it. This is seen from ground. No pseudo or no judo, no other forces. Focus on the simple terms. So box seen from ground. So what you are seeing, the box is getting pressed. So as it is getting pressed, the truck will push it forward. So that is the normal. Now in which direction you are accelerating? Horizontally. So horizontally I will say which law? Second law. Why second law? Because it is accelerating. It is accelerating, so I will say normal reaction by the wall of truck. This is providing it acceleration, so it will be ma naught. And if I see vertically, is the box flying away and going out of space? No, it is there only on the floor of the truck. So vertically no acceleration, means which law? First law. So I will say the floor of the truck is balancing which force? Mg. So lastly I will just say the floor of the truck is balancing the weight of the box and the normal reaction by the wall of the truck, that is providing the acceleration a naught so that this box can move along with the truck. Understood this thing? So this is the main concept that you should focus. What is the usage of a particular force? Is it balancing another force or is it providing for acceleration? If you see that a force is balancing other force, right, and there is no motion or no change in velocity, you will say that I am going to use first law, force balancing, equilibrium. And when I see that there are unbalanced forces and the body is accelerating, then the net external force, net means the resultant, that will provide for acceleration by second law. So in this way we get whatever is required. This is the basis of what we call as Newton's laws of motion, how we apply in different situations. Is it clear to all of you? I hope you got an idea, clear idea of what I was trying to say about contact forces. Okay. So that will be all for today. We'll meet in the next class and we'll discuss other things. Okay. So it was pleasure teaching you all. Thank you.
Hello, good morning students. So today we are going to discuss next common topic of this nomenclature part, that is common name of alkanes and alkyl groups. So common names, why these are important? Sometimes in nomenclature they will give these type of question, that what is IUPAC name of neopentane. So if we do not know structure of common name, how will write IUPAC name of these compound? So that's why these common names are very important. So let us start with first topic, that is types of alkanes, in which we discuss common names. So heading is types of alkanes. So mainly alkanes are classified on three types on the basis of their structure, that how many carbon atoms are present in the parent chain. So these three types are, one is called as normal alkane, one is called as isoalkane, and one is called as neoalkane. So if we write number 1, normal alkane is represented as N-alkane. So what we call this as normal alkane. So normal alkane is that type of alkane in which all the carbon atoms are present in a straight chain. So if all carbon atoms are in straight chain, there will be no branching. These type of alkanes are called as normal alkanes. So what we write, that all carbon atoms are present in straight chain. In straight chain means we can say parent chain also, because if there is only one chain, that will be considered as parent chain. So we can say there is no branching present, or there is no subsequent present in normal alkane. So if we start, for example, if I have to draw structure of normal butane. Now butane, what is word root here? But will represent that total how many carbon atoms are present? 4 carbon atoms. So in normal butane, all 4 carbon atoms are present in straight chain. So CH3, CH2, CH2, CH3. So all 4 carbon atoms are present in which chain? Straight chain. So this is called as normal butane. And if we have to draw structure for normal pentane, now pentane means how many carbon atoms are present in pentane? In pentane, how many carbon atoms are present? So pent is word root 4, how many carbon atoms? Yes, 5 carbon atoms. Very good. So all 5 carbon atoms will be present in parent chain. So 3, 4 and 5. So if all 5 carbon atoms are present in a straight chain, there is no branching. So this is called as normal pentane. Clear? And if we write normal hexane, hexane means how many carbon atoms are present? 6 carbon atoms we have to write in straight chain. So what is structure? CH3, CH2, 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 CH2 and CH3. Total how many carbon atoms are present? 6 carbon atoms are present. Very good. So if we write all for normal alkane, what is condition? That all carbon atoms should be present in the parent chain. Now tell, any doubt in this normal alkane? Any doubt in this normal alkane? That how to draw structure of normal alkanes? Clear? So it is very simple. All carbon atoms in straight chain without any branching. Now next, if we type, next type of alkane is isoalkane. Now this is very important, how to draw structure of isoalkanes. Okay. Now from word root we can identify how many total carbon atoms are present. So less than 1 carbon atom. If total carbon are n carbon, so what we write? N minus 1 carbon atoms. Listen carefully, if total carbon atoms are n, so how many carbon atoms we are taking? N minus 1 carbon atom. They are present in which chain? Straight chain. Okay. For example, if I am saying isopentane, pentane means total 5 carbon atom. So 5 minus 1, 4. So 4 carbon atom will be present in straight chain. So first thing is n minus 1 carbon atom should be present in straight chain. After that, how many carbon atom are left? 1 carbon atom. So this one carbon atom will be methyl branching at second position. This will be methyl branching at which position? Second position. Clear? So if we write example, let us take first example is we have to write isobutane. Now in isobutane you have to tell how many total carbon atoms are present. I am asking total carbon atom, not in parent chain. Isobutane, word root represents total number of carbon atom. So but means how many carbon atoms? Not 6. But means how many carbon atom? 4. Now total carbon atoms are 4. So it means here I am writing total carbon atoms are n. So here total carbon atoms are 4. So 4 minus 1, 3 carbon atoms we have to write in straight chain. So if we write 3 carbon atoms in straight chain, CH3, CH, CH3. So next is numbering is 1, 2, 3. Now one carbon atom which is remaining, that is methyl branching at which position? Second position. So this is second position here, but we have to write methyl branching CH3. So this is structure of isobutane. Now students, you have to tell what is IUPAC name of isobutane. I am asking one question. What is IUPAC name of isobutane? Try to tell IUPAC name for this compound. Venugopal 2-methyl propane. Very good. So this is correct numbering. At second position what is given? Methyl. So if I have to write IUPAC name for this, so what is IUPAC name? It is 2-methyl for 3 carbon atom. It is propane. So common name for this structure is isobutane. And what is IUPAC name? It is 2-methyl propane. Clear? Now next is, what is structure for isopentane? What is structure for isopentane? Pentane means total how many carbon atoms are present? You tell pentane means total how many carbon atoms are present in pentane? Venugopal, total how many carbon atoms are present? Very good. 5 carbon atoms are present. Good. Now 5 carbon atoms are total. How many carbon atoms are in straight chain? N minus 1. So 5 minus 1, 4. So if we write CH3, CH, CH2, CH3. 4 carbon atoms I have written in which chain? Straight chain. Now write down numbering. 1, 2, 3, 4. Now one methyl branching at which position? Second position. So here what is present? CH3. Then can we write IUPAC name for this compound? Tell me IUPAC name for this compound. Students are telling very good. 2-methyl butane. So total 4 carbon atom, word root is butane, and how many substituent are present? 1 substituent at second position. So its name is 2-methyl for 4 carbon atoms. What we write? Butane. Clear? So whenever you have to write isoalkane, write N minus 1 in straight chain. 1 methyl branching is at which position? Second position. But remember, there is one exception in this isoalkane, that is isooctane. That is very important. So there is one exception. That exception is isooctane. Now for isooctane, we cannot apply this rule. So for isooctane, what is important? We should remember what is the IUPAC name of compound. And for IUPAC name, we can draw the structure. Total carbon atoms are 8, but we cannot apply that 7 carbon in straight chain, 1 methyl branching. For this isooctane, what we have to remember? Its IUPAC name. So its IUPAC name is 2,2,4 trimethyl pentane. So this is very important. What we have to remember, that what is IUPAC name of isooctane? 2,2,4 trimethyl pentane. And easily by this IUPAC name we can draw the structure. So if I have to draw structure, pentane means how many carbon atoms I have to write? 5 carbon atoms. So I have written 5 carbon atoms in straight chain. 1, 2, 3, 4, 5. Wait, I will tell about isopropane also. Wait carefully. Wait first this. For this one, 2 methyl are at second position, 1 methyl is at fourth position. I will take doubt for isopropane also, but first listen this. 1, 2, 3, 4, 5. So 2,2,4 trimethyl for 5 carbon atom, what is pentane? So this is very important. We have to remember that isooctane, how to draw structure. Structure is, we have to remember IUPAC name, 2,2,4 trimethyl pentane. Okay. Now one student is asking that why isopropane is not there. Isopropane is not possible because if you take 3 carbon atom, that is always in straight chain. If you take 3 carbon atoms are always present in a straight chain. In 3 carbon atom, this branching is never possible. Student, these are common names. That rules we have made, that how to draw the structure for our convenience. For our convenience, what we have written some rules, we have made that rules, that how to draw these structures, that this is like take n-1 in straight chain and 1 methyl branching. But actually we have to remember that for every common name, what is IUPAC name? For some compounds, same general rules are valid, but for some compounds there are exceptions also. So that's why we have to remember that in isooctane, there is not only 1 methyl branching. How many methyl branching are present? 3 methyl branching. 2 carbon at second position, 1 carbon at fourth position. These are called as common names. And isopropane is not possible. Reason? Because 3 carbon atoms are always present in straight chain. So remember this, common names are names given to some compounds. And for those compounds, we have made these rules. These are not any IUPAC rules that n-1 carbon in straight chain. These rules are made by us to remember these compounds. Here. So any doubt in this isoalkane? Sushant, you are repeating same message. I am telling again. There is no IUPAC rule like that n-1 carbon straight chain. These rules are made by us to remember these compounds easily. Okay. Now next type of alkane, third type of alkane is Neoalkane. Okay. Now what is rule for Neoalkane? That how to find draw structure for neo compounds. So if total carbon atoms are n, then how many carbon atoms will be in parent chain? n-2 carbon atoms are present in straight chain, that is parent chain. And how many carbon atoms are left? 2 carbon atoms. So these 2 carbon atoms are methyl branching at second position. So this is methyl branching at which position? Second position. Now at second position, how many methyl groups are present? 2 methyl groups are present. Clear? So if we take example, let us take neopentane. We have to draw structure for neopentane. Now pentane means total how many carbon atoms? Pentane means total how many carbon atoms? Number of carbon atoms in pentane are 5 carbon atoms. Clear? Now 5 are total. So 5 minus 2, how many are present in straight chain? 3 carbon atom. So CH3, C, CH3. Now how many methyl branching are present? 2. 2 methyl branching at which position? Second position. So this is second position. So 2 methyl branching at second position. So this is numbering 1, This is 2 and this is 3. Okay. Now you have to tell what is IUPAC name for this compound. Question will be there. What is IUPAC name of neopentane? IUPAC name of neopentane. Students are telling 2,2-dimethyl propane. Very good. How many substituents are present? 2 methyl are present at second position. So 2, 2 dimethyl, and for 3 carbon atom, what is word root? Prop, and this is alkane, so propane. So 2, 2 dimethyl propane. So this is IUPAC name for which compound? Neopentane. Next, if we have to draw structure of neohexane, now hexane means total how many carbon atoms? Hexane means total 6 carbon atom. So 6 minus 2, how many are arranged in parent chain? 4. So if we write 4 carbon atoms in parent chain, CH, CH2, CH3. And what is numbering? 1, 2, 3, 4. Now at second carbon, how many methyl branching? 2 methyl branching we have to add. So 2 methyl branching at which position? Second position. So it is CH3, CH3. What is IUPAC name for this compound? For neohexane. Tell IUPAC name for neohexane. Dimethyl butane. Good. 2,2-dimethyl butane. And on total how many carbon atoms? 4. 2 methyl branching is present at which position? Second position. So it is 2, 2 dimethyl. For 4 carbon atom, what is word root? But. And for single bond, it is ene. So it is 2, 2 dimethyl butane. Clear? So these are 3 types of alkane. Any doubt in neoalkane? Tell any doubt in neoalkane, that how to draw structure of neoalkanes. Clear? So all these questions will be there, that what is IUPAC name of neohexane, what is IUPAC name of neopentane. So we should know structure for these common compounds. Okay. Now next is common name of alkyl groups. Next, what we have to discuss, common names of which group? Alkyl group. Now you have to tell what is meaning of alkyl group. So tell me answer, what is meaning of alkyl group? How alkyl group is obtained? Two n plus 1. What is 2n plus 1? Triple bond. I am not asking alkyne. It is alkyl. Students, alkyne is different. Alkyne is triple bond. It is alkyl. ALKYL. This alkyne is a triple bond. I am asking about alkyl. So if you remove one hydrogen from any alkane group, that substituent will be called as alkyl group. Clear? So first point what we have to remember, if we take any alkane group and remove one hydrogen, but we have to remove one hydrogen atom, then group obtained is called as which group? Alkyl group. For example, CH4. What is name of CH4? Methane. If we remove one hydrogen, then which group is formed? CH3 with one valency vacant. Remember what is obtained? CH3, and one valency of carbon is vacant because we have removed one hydrogen. So this group is called as methyl group. This group will be called as methyl group. Clear? If we take CH3, means C2H6, which compound it is? Ethane. Now from ethane, if we remove one hydrogen, then what is formed? C2H5 and one valency vacant. This group will be called as ethyl group. So alkyl is a substituent which is obtained by removal of one hydrogen from alkane. Here, any doubt in this? What is meaning of alkyl group? These are substituents which are obtained by removal of one hydrogen atom from alkane. Now there are different types of alkyl groups. So if we write first type of alkyl group is normal alkyl. So same here, different types of alkyl are possible. Normal alkyl is there, isoalkyl, neoalkyl, secondary, tertiary. So first we are going to discuss about normal alkyl. Now what is meaning of normal alkyl? That hydrogen is removed from normal alkane. Hydrogen is removed from normal alkane and from any of the end carbon. So from any of the end carbon we have to remove one hydrogen atom. That alkyl group will be called as normal alkyl. So simplest example, if we take CH3, CH2, CH3, what is name of this compound? Tell me name of this compound. CH3, CH2, CH3. What is name of this compound? Propane. Very good. What is name here? Propane. And in propane there is no branching. So this is always normal alkane or normal propane. Now we have to remove one hydrogen from any of the end carbon. So either from this CH3 or from this CH3. So if I remove hydrogen, what we get? CH3, CH2, CH2 and one valency is vacant. So this group will be called as which group? Normal propyl, N-propyl. So how normal propyl group is obtained? By removal of hydrogen from which alkane? Propane, and from the end carbon. We are not removing hydrogen from the middle carbon. It is removing from which carbon? End carbon. So that's why it is called as normal propyl. Clear? Next, if I take butane, what is normal butane? CH3, CH2, CH3. What is name for this compound? Now this is normal butane. Now if I remove hydrogen from this normal butane, one hydrogen, then what I get? Normal butyl. But I have to remove from any of the end carbon. Which is end carbon? Either this is end carbon or this is end carbon. So remove one hydrogen minus H. So what we get? CH2, 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 CH3. From here one hydrogen is removed, so one valency is vacant. So this will be structure for which group? Normal butyl. Clear? So what is meaning of normal butyl? That one hydrogen is removed from normal butane and from any of the end carbon. Check. Any doubt in this normal alkyl? Easily you can draw. If you remove hydrogen from any of other carbon other than end carbon, then name will be different. But for normal, we have to remove from the end carbon. Okay. So this is first type of alkyl group. Now second type of alkyl group is isoalkyl. Second type of alkyl is isoalkyl. Now in isoalkyne, what is statement? That hydrogen is removed from isoalkane. Is removed from isoalkane and from end carbon opposite to branching. From end carbon opposite to branching. Here, so this is important. From which carbon we have to remove hydrogen? From the end carbon, from opposite to which one? Where methyl branching is present. So from example, this will be more clear. So if I write CH3, CH, CH3, CH3, you have to tell what is name of this compound. CH3, CH, CH3, CH3. What is name for this compound? Common name you have to tell, not IUPAC name. One alkane is written here and you have to tell what is common name for this alkane. Now Venu is saying isobutane, correct. What is common name for this one? Isobutane. Because we are writing about common name, so what we have to take? Isobutane. So for isoalkane, we have to remove hydrogen, isoalkyl, we have to remove from isoalkane. So what we have taken? Isobutane. Now from which end we are doing numbering? 1, 2, 3. Second position methyl. Then remove hydrogen from opposite end. So if we remove one hydrogen, what we get? CH3, CH, CH3. From this end, CH2. From here, what we have removed? One hydrogen. One valency will be vacant. So now this group is called as which group? Isobutyl group. What is name of this? Isobutyl. So how isobutyl is formed? Hydrogen is removed from isobutane and from the end carbon opposite to branching. We have not removed hydrogen from middle carbon. It is from the end carbon opposite to branching. Now similar type of example if we take, next I am writing a structure. You have to tell what is common name for this. Tell me what is common name for this. Common name for this compound which is shown here. Second example. Total how many carbon atoms are given? 5 carbon atom, 1 methyl branching. So this is structure for isopentane. Now we have to remove one hydrogen from the opposite end of branching. So from here branching is done 1, 2, 3, 4. Which is opposite end? This is opposite end. Remove one hydrogen from here. So what we get? CH3, CH, CH3, CH2. Here one hydrogen is removed. So what is left? CH2. So this group will be called as isopentyl. So how isoalkyl groups are obtained? We have to remove hydrogen from isoalkane and from the end carbon opposite to branching. Any doubt in this isoalkyl group? What about octyl? Same isooctyl, then you have to remove from isooctane from end carbon. But you will not get that isooctyl nowhere. In alkyl, you will get only this simple isobutyl, isopentyl. You will not get about isooctyl, so no need to take tension of that. Now third is Neoalkyl. Now in Neoalkyl, hydrogen is removed from Neoalkane. So here hydrogen is removed from Neoalkane and from end carbon opposite to branching. And carbon opposite to branching. Okay. So we have to remove one hydrogen from Neoalkane and from the end carbon opposite to branching. So if we take example of neopentane, CH3C, CH3, CH3, CH3. So name of this compound is neopentane. This is structure for neopentane. Now from this side we are doing numbering 1, 2, 3, which is opposite end. This is opposite carbon to branching. Remove one hydrogen from it. So what we get? CH3, CH3, CH3. Here what we get? CH2, one valency is vacant. So this group is called as neopentyl. Clear? So whenever we have to write neoalkyl, we have to remove one hydrogen from neoalkane and from the end carbon opposite to branching. Next example, if I write neohexane structure. So what is structure for neohexane? CH3, CH3, 2 methyl branching at second position and 4 carbon atoms in straight chain. Now if we remove one hydrogen, so this is structure for neohexane. Now 1, 2, 3, 4, this is opposite carbon to branching. Remove hydrogen from this. So if we remove, what we get? CH3, C, CH3, CH3, CH2, CH2, one valency is vacant. So this group is called as neohexyl. Clear? So it is very easy to draw structure of neoalkyl, remove hydrogen from neoalkane and from the end carbon opposite to branching. So these three are simple: isoalkyl, neoalkyl and normal alkyl. Now in case of butane, there are two more different types of alkyl group present. Here listen carefully, there will be two different names here: CH3, CH2, CH2, CH3. If we are removing hydrogen from first carbon, that is called as normal butane. But if we remove hydrogen from second carbon, remove hydrogen from which carbon? Second carbon. Then what we get? CH3, CH, one valency is vacant, CH2, CH3. Now these two carbons are identical, both are second to 1, 2, 3, 4, 1, 2, 3, 4. So if we are removing hydrogen from any of the middle carbon, then it is called as secondary butyl. It is called as secondary butyl. I hope you have heard about this degree of carbon in initial classes of this organic chemistry. You have studied that carbon which is attached to two more carbon atom is called as secondary carbon. So from the carbon from which hydrogen is removed, what is degree for this carbon? Secondary. That's why it is called as secondary butyl. So remember this, from butane, if we remove hydrogen from end carbon, what we are getting? Normal butyl. But if we remove hydrogen from second carbon, what we are getting? Secondary butyl we are getting. And next is, if we write isobutane, CH3, CH, CH3, CH3. Same here, in this case, if we remove hydrogen from second carbon, if we remove hydrogen from which carbon? Second carbon, then what we get? If we are removing from end carbon, we are getting isobutane. But if we remove hydrogen from middle carbon, what we get? CH3C, CH3, CH3, one valency is vacant. Now tell me, what is degree for this carbon? What is degree for this carbon? From where hydrogen is removed, what is degree of carbon? I am asking degree. 1 degree, 2 degree or 3 degree carbon? Not 4 degree, it is 3 degree carbon. Carbon is attached with 3 more carbon atom. So this carbon is tertiary carbon. That's why this is called as tertiary butyl. So this is short form for tertiary. So this is called as tertiary butyl and this is called as secondary butyl. Because here hydrogen is removed from which carbon? Tertiary carbon. That's why this is called as tertiary butyl. So in case of butane, there are two different alkyl groups named. What is named? One is secondary butyl and one is tertiary butyl. Okay. Now next I am asking one point. Isopropane is possible or not? Isopropane is possible or not? You tell, isopropane is possible or it is not possible? isopropane is not possible because 3 carbon atoms are always in a straight chain. But if we write propane and remove hydrogen from middle carbon, means second carbon, remove hydrogen from second carbon, then this group is called as isopropyl group. And this group is called as which group? Isopropyl group. Isopropyl. So isopropane does not exist. What exists? Isopropyl. So in case of propane, if we remove from any of the end carbon, normal propyl. If we remove hydrogen from middle carbon, then what is formed? Isopropyl. Here. Now where these common names are used? When we are discussing about nomenclature of alcohols, so can we give this name? You have to tell, right? They will give IUPAC name of isopropyl alcohol. So after nomenclature, you will think alcohol nomenclature is very easy. But now they have combined common name with IUPAC name. What they are saying that write IUPAC name of which alcohol? Isopropyl alcohol. So first we have to draw structure of isopropyl. What is structure of isopropyl? CH3, CH, 1 valency vacant, CH3. This is isopropyl. Now isopropyl alcohol means which group we have to attach here? OH group. So this is isopropyl alcohol. Now what is IUPAC name for this compound? Select the parent chain and write numbering 1, 2, 3. So for 3, word root is prop, single bond in. For alcohol, what we write? Ol. So what is name for this compound? Propane 2-ol. Okay. Similar type of question I am writing. You have to tell name for this. Write IUPAC name of neopentyl alcohol. So this is last question for today. You have to tell IUPAC name of neopentyl alcohol. First try to draw structure of neopentyl alcohol. In neopentyl, where 1 valency is vacant, there what we have to attach? OH group. And then we have to write IUPAC name. So first we have to draw neopentyl alcohol. So first I am writing neopentyl. CH3, CH3, CH2, this is neopentyl. And alcohol we have to add means which group? OH group. So this is neopentyl alcohol. Then how to write IUPAC name? Select the parent chain. So this is 1, 2 and 3. So IUPAC name is 2,2 dimethyl. For 3 carbon atom, propane. And for alcohol is ol. So what is name here? 2,2 dimethyl propane ol. Students, you need to understand these classes are very important. And you are wasting time in chat for unnecessary. So one person is here to delete your chat. And students who want to crack NEET, they does not engage in these type of silly chats. So these topics are very important. So listen carefully in classes. I guarantee you students who will crack NEET exam, only 7 or 8 students who are giving regular answers. So those are very sincere students, they are listening classes. So that's why listen carefully in classes. Here. So this is for today's class, all the common names. In next class, we'll start some basic about isomerism and degree of unsaturation. So students, thank you for today.
Friends, good morning. How are you? Okay, today our body topic is biomacromolecules. Do you know about the example for biomacromolecules? Yes, good morning. One of the best example for biomacromolecule, the protein, polysaccharides, and DNA, RNA like nucleic acids. What is the main criteria to consider all these molecules are biomacromolecules? What is the main criteria to consider a biochemical is a macromolecule? Molecular weight. If the molecular weight is greater than 1000 Daltons, such are called biomacromolecules. Biomacromolecules. Protein is a polymer of amino acids. Amino acids are building blocks of protein molecule. Many amino acids, amino acid 1, amino acid 2, amino acid 3, like there several are binded with another one to form peptide bond, then long chain is formed, that is called protein. Hence we can say protein is the polymer of amino acids, or amino acids are the building blocks of the protein. Amino acid is a brick-like structure, structural unit, structural units. The 20 different types of amino acids are there. Between two adjacent amino acids, peptide bonds are present. This is a peptide bond. With the help of this peptide bond, all the amino acids are linked with each other to form a long chain of amino acids. It is a protein or polypeptides. Polypeptide is another name of protein molecule. Number of amino acids in a polypeptide is different from protein to protein. Give some of the example for proteinaceous food supplements. You might have seen, you might have eaten several types of proteinaceous food materials. Now, please list out. Yes, meat, goat, mutton, chicken, fish, egg, dal nothing but pulses. Red gram, green gram, black gram, pea, beans, all are example of proteinaceous. But the taste of chicken is different from mutton, mutton taste different from fish and egg. But all are proteins. What is the reason for this kind of variation among the proteins in terms of the taste and size and texture? By changing in SY also. Soy is also very good example for highly proteinaceous pulses. Reason from the taste of mutton different from the taste of chicken and other proteinaceous food material. Number of amino acids are different from protein to protein, and sequence of amino acids also different. Sequence of amino acids also different. Different types of amino acids are there. If any kind of polymer is made up of same kind of structural units, these are building blocks or structure unit of a polymer. If all these units are similar or same kind, second block, third block, fourth block, all blocks are uniform, then such type of polymers are called homopolymers. If the building blocks are more than one kind are there, these are called heteropolymers. One of the similarity between these two types of biomolecules, both are polymers. If the polymer made up of some kind of units, it is also made up of some kind of units. But the variation is all the structural units are same kind, the different kind. Same homo, different hetero, different English term. But hetero, technical name of the differ, same homo. These are the polymers or macromolecules are two types, homopolymers, heteropolymers. Now the question assertion, protein is example for heteropolymers. A for assertion, protein is an example for, or all proteins are heteropolymers. This statement A is a true or false? True statement. What is the correct reason that can explain this assertion statement? Proteins are made up of different types of amino acids. Different types of amino acids are found in a protein molecule. Found in a protein molecule. R correct, A correct, and R is correct explanation. Okay, both are true statements and R is correct. Meaning for the hetero, presence of different types of building blocks or structural units. If all the units are same kind, homo. At least only one protein, one amino acid is changed, that is the hetero. It is the first point under the heading protein. Proteins are heteropolymer of amino acids. Next, there are polypeptides because many amino acids are there. Observe here amino acid 1, 2, 3, 4 like that. So many are there. That is the meaning for poly. Next, linear chains of amino acids linked by peptide bonds. What kind of chemical bond is essential to link to adjacent amino acids? Peptide bond. Peptide bonds are formed from carboxylic group of one amino acid to the amino group of another amino acid. At the time, one water molecule liberates out. Hence, peptide bond formation is also called as the dehydration reaction. Peptide bond formation is one of the example for dehydration chemical reaction. Dehydration. Alpha carbon of an amino acid, one valency position, functional group, carboxylic group, hydrogen element. At another place, amino group is there, NH2. Alkyl group. Alkyl group is different from amino acid to amino acid. Remaining all the amino acids, these three functional groups are same. Amino acid number 2, it is amino acid number 1. Second amino acid, same. Alpha carbon, hydrogen atom, carboxylic group, alkyl group, NH2 amino group. Amino group. OH group in carboxylic group of first amino acid. One hydrogen atom of the amino group in second amino acid contribute to form liberation of water. Then a bond is found between these two amino acids. That bond is called peptide bond. So finally we can conclude peptide bond formation is example for dehydration reaction. So listen one statement, say this is the statement is right or wrong. To form a peptide bond, amino group of first amino acid, carboxylic group of second amino acid is involved. Say, is it true or doubt? True or false? Peptide bond formation is carried out by first amino group of first amino acid to carboxyl group of second amino acid. No. Wrong. This statement is false, not true. In first amino acid, carboxyl group is participated. Amino group not participate in formation of first peptide bond. But amino group of second amino acid involved. It is the second amino acid. Carboxyl group of first amino acid, amino group of second amino acid involved in formation of first peptide bond. Whereas in second peptide bond formation is alpha carbon, hydrogen atom, carboxyl group of this amino acid, alkyl group, NH2 amino group. It is amino acid number 3, third amino acid. Peptide bond number 2 is formed between carboxyl group of second amino acid to the amino group of third amino acid. This peptide bond number is the second peptide bond. PP bond. Full form of the PP? Peptide bond. First peptide bond is present between carboxyl group of first amino acid to amino group of second amino acid. Whereas in second peptide bond is formed between carboxyl group of second amino acid and amino group of third amino acid. Likewise, 25th peptide bond is formed in between. If the peptide bond number is 25th, it is found between carboxyl group of 25th amino acid, amino group of 26th amino acid. Carboxyl group of 25th amino acid, amino group of 26th amino acid. Likewise, one more question. These two are two adjacent amino acids. This peptide bond is the fifth one. The fifth peptide bond is contributed from carboxyl group of fifth amino acid, amino group of sixth amino acid. Amino group of sixth amino acid. Okay, is it clear? It is one amino acid. Amino acid, short form AA. Amino acid number 2, 3, 4, 5, 6, like several, up to thousands or lakhs of amino acids are joined with another one or linked with another one by forming peptide bonds. Finally, this long chain of the polymer of amino acids is known as a polypeptide chain. This is the first amino acid. It is the last amino acid. In this chain, especially at the first amino acid, amino group is the free, not engaged with any kind of peptide bond. Whereas in last amino acid, carboxyl group is the free. Except first amino acid and last amino acid. In remaining all the amino acids, both the groups, amino group, carboxyl group, engaged with two different peptide bonds. It is the second amino acid. This is the third amino acid. Even in third amino acid also, amino group engaged with this peptide bond. In same amino acid, it is the carboxyl group engaged with this peptide bond. In every amino acid, amino group and carboxyl both are engaged with two different peptide bonds, except first and last amino acids. In first amino acid, only carboxyl group is busy or engaged with peptide bond, but amino group is free. Whereas in last amino acid, amino group is engaged with this last peptide bond, but carboxyl group is free. Hence, another name of this last amino acid is C-terminal or C amino acid. C-terminal. Terminal means end, last. And this one of the end of this chain is C-terminal end. The first end of the chain is N-terminal. N-terminal. Or another name of first amino acid is N-terminal amino acid. Last amino acid of this chain is the last C-terminal amino acid. Why this amino acid is called the C-terminal? Because the carboxylic group is the free. Whereas here amino group is the free, hence it is the N for amino, C for carboxylic group. It is about the polarity of these two ends of polypeptide chain. Observe the images given in board. In this long polypeptide chain, this is the first one is N terminal because amino group is the free. The last end is the C terminal because C for carboxylic group is the free. What are proteins? Proteins are the polypeptides. They are linear chains of amino acid linked by peptide bond. Peptide bond is found between two adjacent amino acids. Two adjacent amino acids. OH group of the carboxylic group in one amino acid. Hydrogen atom in the amino group of next amino acid. Engage it to form polypeptide bond. At the time water molecule liberation is there, so it is a dehydration reaction. Peptide bond formation is example for dehydration reactions. Each protein is a polymer of amino acid. There are about 20 types of amino acids are there. 20 types of amino acids, not 21. 20 types of amino acids are involved in synthesis of proteins. Already learned, protein is an example for heteropolymer, not as in homopolymer. Whereas in homopolymers, only one type of monomer repeating n number of times. Now the different structural levels of the protein. During the protein formation, the first formed structure is the primary structure. Later, the primary structure gradually turned into secondary structure, secondary form. Primary form modified into secondary. After that, secondary form modified into tertiary. It is a functional form of protein. But rarely quaternary form is there. 90% of the proteins only tertiary form is there. Now, primary turned into secondary, secondary finally modified into tertiary. Quaternary forms are absent, but rare kind of proteins only. Tertiary form is also furtherly turned into quaternary form. These are main three common levels of protein structures: primary, secondary, tertiary. Rarely fourth structure is also there, that is the fourth form, quaternary form. Identify the difference between primary, secondary, quaternary. Observe here, primary from only long chain of amino acids. Primary is a long chain of amino acids. Secondary form, the chain is spirally coiled in right hand direction. This form is called as the alpha helix. Sometimes it may be a beta pelleted form. These two are secondary forms. Secondary form found in either alpha helical form or beta sheet form. Sheeted form or helical form are the two different forms of secondary protein. Secondary proteins are found in either helical form or sheet form. It is a highly condensed form, appears like a one woolen ball, spherical ball. That is the tertiary form. Just wait. Now strip cut చేసేవాడిని. Observe here, this one paper piece is there. long chain without any kind of foldings. In this chain, one end is the N terminal, another end is the C terminal. Now it is the primary structure. First form of the protein gradually turns into secondary by coiling in right hand direction. Are you observing? It is secondary form, helices form. Helices, alpha helical form is the secondary form. Just helices are formed. Okay. Straight chain without helices or folding primary. If the helices are there, secondary form. It is secondary. Okay, na? In secondary, one more form is also there. One more form, observe here. In some kind of proteins, instead of helical form, beta palated sheet form is there. So secondary form is found in either helical or beta palated form. Now it is a beta palated form. Observe here. Beta palated. Ridges, ridge, furrow is there. Okay. Instead of alpha helical, beta pallid is the another form of the secondary protein. So primary form should be turned into either helical form or this beta pallidated form. Now about the tertiary form. It is very easy to make the tertiary form. It is completely folded and become as a very short, highly condensed small granule. It is the tertiary form of the protein. It is the functional form. It is the primary. Primary turn into secondary. Again secondary turn into tertiary. One tertiary protein. Rarely quaternary is formed. It is small granule is balls. This is the one tertiary. Second tertiary. This is a tertiary number 3. Tertiary number 4. One tertiary, second tertiary, third, 4 are binded to form quaternary hemoglobin structure. In structure of the hemoglobin, 4 tertiary units are joined together to form quaternary. Example for quaternary form of the protein molecule. Example for quaternary form of the protein molecule. Hemoglobin. Yes. Good. Hemoglobin. Okay, na? What is the name of each and every unit of this hemoglobin? In 4 units are there. The name of each and every unit is heme. 4 heme units are attached to iron. So iron is essential for joining of these 4 heme groups to form hemoglobin. If any kind of iron deficiency is there in your body, that leads to hemoglobin deficiency. So you have to take plenty of or adequate level of iron food like apples and one leaf vegetable gongora. These are essential to form iron. Iron essential to join all these 4 heme units finally to form hemoglobin. So hemoglobin is the fourth form of protein, that is the quaternary form. But majority of the proteins are in these 3 forms only. First formed is the primary, that modified into either palated or helical secondary form. The secondary form finally turned into tertiary. Rarely such tertiaries are more than one here. It is the 1 unit, 2nd unit, 3rd unit, 4th unit. The 4 units these 4 units linked with one element to form quaternary form. Tell me once again, total how many forms of proteins are there? Mostly 3, rarely 4th form. First formed form is primary, modified into secondary, secondary turned into tertiary for the functioning of a protein. It is the only functional form, or act as a catalyst like enzymes. Tertiary is a rare one. Next, another very, very important one. In entire biosphere, Rubisco is the abundant type of protein in this entire universe, including animal kingdom and plant kingdom. Largest protein or abundant protein is highest quantity of the protein is Rubisco. Full form of the Rubisco, the ribulose, bisphosphate, carboxygenase and oxygenase. RU, ribulose, BAS, bisphosphate, C for carboxygenase and O for oxygenase. This enzyme is essential for photosynthesis and hence it is present in chloroplast. Chloroplast, yes, dark reaction of the chloroplast. Good. Collagen is abundant protein in animal world, even in our body also. Maximum protein is in meat form in our body also. In that abundant kind of protein is collagen. Collagen protein acts as a connecting link between our bone tissue and muscle tissue. It is also present in just below the skin. Apply a pressure on skin, there is no damage of the skin, much damage, because just under the skin or collagen pigment is there, collagen protein is there. So collagen is a kind of abundant protein in animal world. In both animal and plant or entire living world, abundant protein is biosphere, Rubisco. Try to give answer for these questions. Proteins are linear chains of amino acids are linked by type of bond between two adjacent amino acids of the protein molecule. Third option, yes, peptide bond. Peptide bond. Next question. What are the functional groups of an amino acid participate in peptide bond form? Amino group and carboxylic group. Amino and carboxylic groups. A protein, imagine as a line, for example, this is a line, left hand represented by first amino acid, right hand represented by last amino acid. Yes. What is the another name of first amino acid and last amino acid? What are the another names of first amino acid and last amino acid? First amino is also called as N-terminal. Last amino acid is the C-terminal. Last amino acid is C-terminal. First amino acid is N-terminal. First amino acid is the N-terminal. This one, because amino group is the free. Last amino acid is the C-terminal. This one, because the carboxylic group is the free, not engaged in peptide bond. That's why that is the C-terminal. It is about the two polarities of this primary structure of the polypeptide chain. Primary structure of polypeptide chain, yes. The thread is folded in the form of either a helical form, it is a helical form, to form alpha helical secondary structure. Sometimes it may turn into plated like foldings. It is the beta palated sheet form. Protein doesn't exit throughout an extended rigid rod. Answer for this question. Polymer of amino acids is polymer of amino acids. Yes, first option protein. Polymer of sugar molecules is For example, here one sugar molecule is given. That polymer of sugar is known as polymer of sugar is polysaccharide. If that structural unit is a nucleotide, the polymer of nucleotides is DNA and RNA. DNA and RNA. What are the structural units of the DNA, RNA? Nucleotide. The structural units of the polysaccharide? Sugar. Sugar is English word. The technical name of the sugar is the saccharide. Saccharide, sugar. What is the Hindi name of the sugar? Actually, sugar is English term. What is the Hindi name? Chini, yes. Or one more name, shakkar. The term saccharide derived from shakkar. Shakkar, saccharide. Many sugar in its polysaccharides. Like protein, it is also another kind of polymer. Next, the primary structure of protein determines. Read the question and give the answer. Saraswati, give the answer. Primary structure of protein determines sequence of amino acids. Second option, sequence of amino acids. Next, one more question. The most abundant protein in animal world or animal kingdom? Most abundant protein in animal world or most abundant protein in human body? That protein acts as a connecting link between our bony tissue and skin. Yes, collagen. Collagen. Next question. In a protein thread, last amino acid is called. Last amino acid of this protein. Yes. C terminal. First amino acid is N terminal. What is the C? C for? Full form of the C. What is the full form of the C? C for carboxylic group. Carboxylic group is the free at last amino acid, but amino group is the free at first amino acid. Next biomacromolecule is the polysaccharides. Next macromolecule, protein chapter completed. Second biomacromolecule is polysaccharide. The structural units of this polysaccharide are sugar molecules. Sugar, English term. Saccharide, technical name or scientific name. If the more sugars are joined with another one to form a long polymer, that is polysaccharide. It is another class of macromolecules found in acid insoluble pellet. No need to learn at this class. I will explain about it in next class. Next, polysaccharides are long chains of sugars. I think you learn in chemistry class about the classification of carbohydrates. You might have learned in higher classes based on number of sugar units. Based on number of sugar units, present in each molecule. Carbohydrates widely classified into 4 categories. Such are one is monosaccharide. What is the meaning for monosaccharide? If a molecule consisting of or carbohydrate is made up of only one sugar, mono, one sugar, saccharide, such are monosaccharides. Glucose, fructose, ribulose, all are example for monosaccharides. All are example for monosaccharides. If number of sugarides are 2 to 10, such are oligosaccharides, OLIGO, oligosaccharides. Oligosaccharides. If the number of sugarides are more than 10, 20, 30, 40, 100, 1 lakh, 10 lakhs, such are polysaccharides. In our biology syllabus, only polysaccharides included, but you have to learn about all the types of oligosaccharides, monosaccharides in chemistry syllabus. In second year NCERT textbook, all these things are mentioned. In our biology syllabus, only polysaccharides are there. Tell me once again, what is the main criteria to classify the carbohydrate into 3 categories? Number of sugarides. Only one sugaride is there, mono. 2 to 10 sugarides, oligo. More than 10 sugarides, polysaccharides. Like polypeptide chain, here also polysaccharide is formed by forming a special bond between 2 adjacent sugar molecules. What kind of bond is formed between 2 adjacent amino acids of the polypeptide chain? Peptide bond. But whereas in polysaccharides or carbohydrates, glycosidic bonds are present. It is the glycosidic bond. Glycosidic, all these are structural units, nothing but sugar molecules. Okay. Amino acid to amino acid, peptide bond in a protein. But sugar to sugar, glycosidic bond is found in polysaccharides. One of the example for polysaccharide, starch. Cellulose is also one more example. Okay. What is the basic difference between protein to polysaccharides? Similarities are protein and polysaccharides, both are polymers, no doubt. But basic difference is the structure units are sugars in polysaccharides, amino acids in protein molecule. Bonds in protein, peptide, whereas in polysaccharide, the bond between 2 adjacent sugar molecule is glycosidic bond. Glycosidic bond. Yes, glycosidic bond in polysaccharide. Identify this diagram. It is the one sugar or saccharide. In the sugar, it is the first carbon, second carbon, third, fourth, fifth, last carbon is the 6th one. So 6 carbon contain one hexose sugar molecule. It is maybe either glucose or fructose. Glucose or fructose. It is also one more sugar molecule. Here also the numbering of the carbon 1, 2, 3, 4, 5, 6. OH group is found at the first carbon of one sugar. OH group is found in 4th carbon of another sugar molecule, involved in formation of a glycosidic bond by removing one water molecule. So the name of this bond is glycosidic. Glycosidic bond formation between 2 successive sugar molecules is an example for dehydration reaction. This glycosidic is also called as 1,4 linkages, because first carbon of sugar and fourth carbon of sugar, first carbon of another sugar involved in this glycosidic linkages. Hence another name of it is the 1,4 linkage. 1,4 linkage. What kind of bonds are found between 2 monosaccharides? Glycosidic. Glycosidic bond formation is example for dehydration. Next, types of polysaccharides. Types of polysaccharides. These are polysaccharides are two different types. Homopolysaccharides, some are heteropolysaccharides. Some are homopolysaccharides, remaining all heteropolysaccharides. All these are example for homopolysaccharide. Starch, cellulose, glycogen, inulin. All these are homopolysaccharides. Because all the sugarides are same kind. Observe very clearly in these images and identify difference from one polysaccharide to another polysaccharides. Starch, rice flour, wheat flour are good example for starch. Cellulose, cotton, paper, cloth materials are example for cellulose. Glycogen is the form of reserve food material in animal body. Inulin is also kind of reserve form of food material in some kind of tubers. What is the major variation between major chemical arrangement of sugar molecules in these four types of polysaccharide? Identify the variations here. Starch and cellulose. All sugar molecules are found in chain. That chain shows the helices. Helical polysaccharide is the starch. Okay. Helical form is there. Entire chain shows some helices. Whereas cellulose, there is no helices, straight chain of one sugar molecule. Second chain, third chain, like that, so many chains are there, but both two adjacent chains are interlinked with by glycosidic bonds also. It is the cellulose. Okay, tell me once again what the difference between starch and cellulose. In starch, helices are present like a secondary structure of the protein molecule, whereas in cellulose, only straight chains are there, but such straight chains are linked with the other one. In case of glycogen, it is the reserve form of food material in human body or animal body. Branches are present in a chain. Here there is no helices, side chain, but branches are there. I will give some statements, say true or false. In starch, polysaccharide chain is the unbranched. True. Helices are absent in cellulosic polysaccharides. It is also true. Unbranched helical polysaccharide, starch. Non-helical unbranched straight chains of the polysaccharides, cellulose. Cellulose, a long chain of sugar molecules with several branches, glycogen. And what are the common features between three types of polysaccharides? Some similarities are there among these three. Identify the similarities. What are the common features exhibited by starch, cellulose and glycogen? Every structure unit is the glucose. These three are homopolymer of glucose, homopolymer of glucose, homopolymer of glucose. But inulin is different. It is the homopolymer of fructose. What are the structural units or building blocks of the inulin? Fructose. In glycogen, cellulose, starch, glucose are the building blocks. Cellulose is a polymer of polysaccharides consisting of only one type of monosaccharides like glucose. These are straight chains, or many number of chains are there. Cellulose is the homopolymer. Each and every saccharide is a glucose molecule. It is the storehouse of energy in plant tissue. storehouse of energy in plant tissue, whereas the storehouse of energy in animal tissue, storehouse of energy in animal tissue. If the plant term replaced by animal, then answer for this question, what is the reserve form of food made in animal or storehouse of energy in animal tissue? Answer for this question. Quick. Storehouse of energy. Somebody said mitochondria. Wrong answer. Mitochondria is the powerhouse of the cell, ATP storing structure. Storehouse of energy in plant tissue is the cellulose, whereas in animal storehouse is the glycogen. Glycogen is the reserve form of food material. Yes, glycogen. Yes, good. Mitochondria is the powerhouse of the cell. Why the mitochondria are called as the powerhouse? Due to storage of cellular currency of the cell or cellular energy, ATP. Okay, in animal tissue, storehouse glycogen. In plant tissue, storehouse of energy is cellulose. No, sorry, storehouse of energy in plant tissue, that starch, whereas in animal cells, the glycogen is there. Storehouse energy in animal cell, glycogen. It is the glycogen. All molecules are sugar molecules, and glycosidic bonds are found between two adjacent sugars. Next, inulin. It is the polymer of fructose. Instead of glucose molecules, fructose is found in polysaccharide, that is inulin. Plant cell walls are made up of cellulose. Paper made from plant pulp cellulose. And another kind of polysaccharides, complex polysaccharides. Okay, polysaccharides proteins completed. In next two class, I will explain nucleic acids, DNA and RNA. That is very, very important for a NEET point of view. In first year intermediate, second year intermediate, one common topic and large, highly weightage topic is the nucleic acid, DNA. It is the basics for remaining all chapters like genetics and molecular biology and biotechnology, and for biomolecules, it is one of the commonest included part. Biomolecules I will explain in next two classes. Okay, and bye.
So very good morning to all of you students. Stars. Yeah, good morning Madhu, Jayashri, Archita, Miki. Yeah, very good morning to all of you. How are you? How are you? कैसे हो? ఎలా ఉన్నారు? How are you? Good going. That's good. That's good. That's good. Okay. Okay. Yeah. Coming back. Last time we got an introduction about human excretory system. So we discussed about kidney, cortex, medulla, notch, hilum, pelvis, ureter, calyx, those things, right? Guys, human excretory system, it mainly consists of a pair of bean-shaped kidneys attached to pair of ureters, opened into a single bladder, and urine goes out through a single urethra. 4 components: kidneys, ureters, bladder, and urethra, right? And as I mentioned you, each kidney consists of millions of nephrons, those tiny tubular structures referred as nephrons. So each kidney has at least 1 million of these nephrons. So please remember, whenever we eat food, whenever we digest food, the digested food gets absorbed into blood, and this food will definitely consist of ammonia. From the blood, ammonia first goes into liver. Inside liver, ammonia gets converted to urea. Inside liver, very harmful ammonia gets converted to less harmful urea, and this urea will be sent to kidneys, and kidneys will successfully mix urea with some amount of water and excrete it outside. Now question for you: which organ is responsible for excretion of urea? Kidneys. Which organ is responsible for conversion of ammonia into urea? Liver. Guys, formation of urea is done by liver, whereas elimination of urea was done by kidneys. So how does kidney eliminate urea? Kidney is composed of many tiny tubular structures. We refer them as nephrons. So I will show you a normal basic cartoon picture of a nephron. Follow me carefully. Please see this, guys. Focus here. Very easy thing, very easy. A nephron has got a cup-like structure, double-walled. This cup-like double-walled structure, we refer that as Bowman's capsule. Okay, and this structure, it continues as a highly coiled tube, again raises up, see, this is a highly folded tube-like structure, Guys, this double wall structure was known as Bowman's capsule. Okay. This folded tube-like structure is known as proximal convoluted tubule. And before you learn this, let me tell you a small example in English. In English, we have got this difference. Big thing is book, small things are booklet. Big thing is river, a small thing is riverlet. Big thing is cigar and small thing is cigarette. Big thing is organ, small thing is organelle. Big thing is tube, small thing is tubule. If you add suffix, size of that structure will be decreased. Book, booklet, river, riverlet, like this. So, whenever we say tubule, proximal convoluted tubule, why should we say that tubule? Because tubule is much smaller than compared to tube. So, and convoluted, what do you mean by convoluted? It has many folds, many turns, convulsions. Simple. And it is very much near to Bowman's capsule. Therefore, near, what was the synonym for near? Proxima, proximal. So, as this part was very near to Bowman's capsule, we should say that as proximal convoluted tubule. Same time, this part was bit far from Bowman's capsule, therefore we have to say that as distal convoluted tubule. See, Bowman's capsule, PCT, DCT, and there is a U-shaped loop-like structure. Right? This was called as loop of Henle, or just call it as Henle's loop. And each nephron, it is loop of Henle, Jayashri, not loop of Helena. It is Henle's loop of Henle. Good. And every nephron opens into a big duct-like structure, a big tube-like structure. This is referred as collecting duct or collecting tubule. Your wish. You can call that as anything. Mainly 5 parts. Just I am showing you tubules only. Each nephron has 2 parts. A network made up of blood vessels called as glomerulus and tubules. See first. I am showing you, but guys, I am only showing you tubules. Bowman's capsule, PCT, loop of Henle, DCT, and collecting duct. And as I told you, a blood vessel which enters kidney was renal artery. Renal artery enters kidney. It gets divided into many small renal arterioles, and these arterioles enter nephron. How about, guys, see this carefully? So, renal arterioles, observe thickness. Renal arterioles, it enters into Bowman's capsule, gets into many branches, will form a network-like structure, and finally it exits out. The arteriole which is entering into Bowman's capsule, this was arteriole which was entering into Bowman's capsule was referred as afferent arteriole. Same time, guys, arteriole which is going out of Bowman's capsule, this was referred as efferent arteriole. So afferent arteriole enters Bowman's capsule and efferent exits Bowman's capsule, isn't it? And this arteriole has become capillaries and formed a network-like structure inside Bowman's capsule. A network-like structure made by capillaries inside Bowman's capsule. This is called as glomerulus. Yeah, guys, understood? So Bowman's capsule, PCT, loop of Henle, DCT, collecting duct. Done. Afferent arteriole enters Bowman's capsule, makes glomerulus and exits as efferent arteriole. And once efferent arteriole comes out like this efferent arteriole will form a capillary around DCT, capillaries around loop of Henle, as well as they also surround around PCT and then go out. Telling again, efferent arteriole will span around DCT, loop of Henle and PCT also. This structure which is formed by efferent arteriole around PCT, DCT and loop of Henle, we refer that as peritubular capillaries. Okay, peritubular means perimeter, surrounding, like this. But same time, near loop of Henle, these peritubular capillaries will form a network-like structure also. Near loop of Henle, peritubular capillaries will form a network-like structure like this. This network-like peritubular capillaries adjacent to loop of Henle was called as vasa recta. Done? That was vasa recta. Vasa recta is peritubular capillaries, but at which location? Loop of Henle. Now you saw this, and now recite this. So Bowman's capsule, PCT, loop of Henle, DCT, collecting duct. Correct? Bowman's capsule, PCT, loop of Henle, DCT, collecting duct. Done? Now, afferent arteriole enters Bowman's capsule, divides into capillaries, forms glomerulus and exit out as efferent arteriole. Yes. Now this efferent arteriole form peritubular capillaries around DCT, vasa recta with loop of Henle, again peritubular with PCT and goes out. See this. Peritubular capillaries around DCT, vasa recta near loop of Henle and peritubular with PCT and goes out. Done? So that was the simplest depiction of a nephron. So glomerulus and renal tubule. So pink thing was blood glomeruli and green structure was renal tubule. Therefore, typically a nephron consists of glomerulus network and renal tubules. Blood coming through glomerulus will be filtered by renal tubules. That was the main intention of becoming like this. So blood coming into glomerulus will be filtered and thus urine or renal fluid will be passed into these tubules like this. Okay, so we'll see what was the basic mechanism how blood gets filtered. Guys, you have to see this picture clearly. Now tell me the difference. Afferent arteriole is very thicker, bulky, big tube, but efferent artery is very thin. Depicted here also. Afferent is having more diameter than compared to efferent. You can imagine like this. Afferent, it becomes efferent like this. Afferent is having more diameter, but efferent has lesser. This is afferent diameter. Diameter of afferent arteriole and diameter of efferent arteriole. Afferent is always much having more diameter than compared to efferent arteriole. So you can imagine now here at this location you can imagine glomerulus, right? Isn't it? See this very carefully. When blood is passing through, afferent arteriole, it has some pressure, 120, 140, 180, something. It has some pressure. Once it comes into glomerulus, obviously glomerulus has capillaries which has lesser diameter. Obviously velocity of blood will increase, blood pressure will increase, isn't it? Once blood passes through glomerulus, because of decrease in size of blood capillaries, definitely there will be increase in blood pressure. Because of this increase in blood pressure, through these glomerular capillaries, all 99% of water in blood, small ions and molecules in blood, some soluble molecules in blood will be filtered and coming into renal tubule like this. See this. Inside glomerulus, the capillary size is very small, isn't it? As there is very clear difference between diameter of afferent and efferent arterioles. This is afferent, this is efferent. So suddenly inside glomerulus blood pressure gets increased. Because of this blood pressure, water, minerals, ions, small soluble molecules, sometimes hormones may filter out of blood and they drop inside this PCT. these molecules cross Bowman's capsule and they drop, they fall into Bowman's capsule, they enter PCT, they enter renal tubules. Guys, large proteins, RBC or any cell or platelets, as they're very big, they will not cross Bowman's capsule. They will stay in blood itself. But what can cross Bowman's capsule and come into PCT, renal tubules? Water, plasma, water, mineral ions, soluble hormones and molecules, they can easily cross Bowman's capsule and come into renal tubules. The liquid which got filtered from blood, you have filtered blood. This filtered blood is called as renal fluid. As this filtration is happening at very high pressure, this filtration happening at glomerular level is actually called as ultrafiltration. Not normal filtration, it is ultrafiltration because it was happening at very high pressure. The first step of urine formation, ultrafiltration. So plasma, water, ions, minerals, soluble proteins, soluble hormones, they will easily filter out from glomerulus and enter Bowman's capsule into renal tubules. The liquid which got filtered from blood is referred as renal fluid. Renal fluid is almost same as plasma. Renal fluid is almost as blood, except renal fluid does not consist of large proteins or RBC, WBC platelets. What do you call those combinedly? Formed elements. Renal fluid does not have formed elements, or they do not have any large proteins also. They are almost, the composition of renal fluid is almost same as that of plasma. Okay. Now, the thing was, per minute, almost per minute, almost 1100 to 1200 ml of blood was filtered in kidneys, and of which, I'm telling you again, per minute 1100 to 1200 blood was filtered and almost 125 ml of filtrate was formed. Guys, as you already know that heart pumps 5 liters of blood per minute, isn't it? You learnt about cardiac output, right? Heart has got ability to pump 5 liters of blood 1 minute. The 5 liters blood pumped by heart, how much blood is reaching kidneys? Almost 1/5, isn't it? Heart was pumping 5 liters of blood per minute and kidneys were receiving almost approximately 1.1 liter. So we can say that 1/5 of the blood pumped by heart is coming to kidneys. So per minute 1100 to 1200 ml of blood will be filtered, and that will be remaining with. So once you filter that much blood, how much filtrate was formed? 125 ml filtrate was formed per minute. We call it as glomerular filtration rate, GFR. What is GFR? Glomerular filtration rate. Now we got a question. If 125 ml of fluid is formed in 1 minute, correct? What about 1 hour? So obviously 125 into 60. In 1 day, how much it will be? 125 into 60 into 24. It is almost 180 liters per day. Isn't it? If you are filtering that much blood, if you are forming 125 ml of filtrate, guys, 125 ml of renal fluid is formed each minute. So per one day, you can do number of minutes into number of hours. You'll be getting 180 liters of filtrate per day. I mean 180 liters of filtration. 180 liters of filtrate was formed per day. Now the problem is this: our nephrons or our kidneys or filtration is not a perfect process at all. Don't trust in them, because along with useless substances like urea, ammonia, uric acid, your nephrons have also filtered many useful substances too. Along with useless substances, nephrons also filtered useful substances, which means this filtrate consists of, yes, they have useless particles as well as useful also. This filtrate consists of useless things as well as useful things also. So glomerulus has done a mistake. Yes, because it was supposed to filter useless things. It was supposed to get rid of urea, but it is allowing other molecules to go through it, which is a mistake. But how to rectify this mistake? We know that even if you got 100 liters filtrate, how much urine are we excreting every day? 1.2 to 1.5 liters. Which means 99% of filtrate was not getting excreted, urinated. We're only excreting 1.5 liters per urine per day. Which means almost 99% of filtrate will be taken back into body. What do you call this? Reabsorption. Why? See guys, reabsorption is a solution. It is a solution for mistake done by glomerulus. Now I have a question for you. If nephrons are taking back useful things, we were using the term reabsorption. Now my question to you is, why should we use this term reabsorption? Why not just absorption? Think about it. Why should we use the term reabsorption? Why not absorption? Because first time absorption took place in intestine. Food. You absorbed food through intestine into body. Now you're again absorbing useful molecules back into body. Yes. First time absorption in intestine. This is second time, right? Therefore it is referred as reabsorption. Always remember this logic. Somebody may ask you. So this reabsorption is done by PCT, DCT, collecting duct also. Therefore we refer that as tubular reabsorption. Second event in urine formation. What is the first event? Ultrafiltration. So once you ultrafilter blood, got some fluid, and in this fluid there are many useful substances which must be reabsorbed by PCT and DCT. Yes. And reabsorption might be passive, active. If you were to absorb calorie food, glucose, amino acid, you may need some energy, active absorption. If you were to absorb back some excreta like urea, uric acid, they might be made passively. But if you want to absorb water, in PCT it will be passive process, but when you go to DCT it will be forcible. So water will be first absorbed passively, then later it will be absorbed actively also. Done. Guys, am I clear till this point? So blood is getting filtered out, fluid is formed. So what is the step? Ultrafiltration. So in that fluid also, important things will be reabsorbed. What do you call this step? Tubular reabsorption. And after doing this also, even after performing tubular reabsorption, there is still a problem, because our urine or renal fluid may consist of harmful ions which must be sent outside. Along with this, PCT, DCT and collecting duct, they were lined by cuboidal epithelium anyway. Along with reabsorption. Okay, guys, listen to this. Ultrafiltration got over. Reabsorption got over. Body absorbed many things. But when you absorb many things into body, obviously your body will become acidic. Your body will become acidic. So body should never become acidic, because pH of a cytoplasm is basic. Blood pH is basic. And most of our enzymes work in basic alkali pH. And we should also eat food which maintains body basic. We should not eat or drink any food which makes your body acidic, because if your body becomes acidic, there is very high chance that you may contract cancers in near future. That's why in earlier days, before 4 or 5 years, water filters made acidic water. But now a technology came in, you learned about this, alkalich. RO water which you are drinking now should be alkaline in nature. Drink hard water, not soft water. Understood? So the first step in urine formation was ultrafiltration. Second step was tubular absorption. Now even in this absorption also, just like ultrafiltration, even tubular absorption is not a perfect process. It was also a faulty process. It absorbed everything, which is not good thing. Therefore, realizing their overaction, they overdid their work. Realizing it, these cells of PCT and DCT, they will now push protons, potassium, excess ammonia, excess urea into this renal fluid. Yes, they absorbed everything, and from those absorbed things, they will again send back protons, potassium, ammonia, urea into filtrate. Why should they do this? Because if they lose protons mainly, body will become basic. And when this protons go into urine, urine will become acidic. Question: why urine was acidic? Because urine has more protons. Why body was basic? Because body got rid of more protons. Therefore, these tubules, along with reabsorption, they also secrete these chemicals into filtrate to maintain your acid-base balance in body. Most credible thing. That was one of the best thing nephrons can do. As I told you, ultrafiltration is good thing but not perfect. Tubular absorption is good thing but it's a bit of overdoing, overacting. And finally, these tubules again secrete some chemicals into filtrate to maintain acid-base balance. What do you call this? Tubular secretion. Done. So main three steps of urine formation were now you got like this. I told you that things were discovered, made sequenced, and then learned. Not like that. There was some topic, you get a side heading, some steps. No, do not follow that. Learn things how they were discovered, not learn things how they were in your textbooks. Do not follow sequence blindly. Ask it how it was discovered, how it was invented. So who did this? How they did this? So think like an author, not like a student. Then you learn more things. Therefore, urine formation, initially filtration, then absorption, finally secretion. Because filtration was too much, filtered everything. Absorption is too much, absorbed everything. So who is the final savior? Secretion. So absorb too many things. So at least let go something, because you have to maintain acid-base balance. What do you call this process? Tubular secretion. Therefore, urine formation includes three steps: ultrafiltration, tubular absorption, and tubular secretion. Guys, am I clear till this point? Done? Understood? Yeah, shall I ask you some questions? Done? Yes. How much ml of renal filtrate was formed in 1 minute? What is the glomerular filtration rate per 1 minute? How much ml? Type it. Per minute, not per day. Per day is 100 liters anyway. Per minute, 125 ml. Very good. Question 1. Done. Question 2. Now, mammals excrete urea. Correct? Therefore, mammals were referred as ureotelic. What do you call this phenomenon? Ureotelism. Isn't it? Question 3. Among ammonia, urea, uric acid. Among ammonia, urea, uric acid, which is most toxic, therefore requires more amount of water to excrete. Which is more toxic, which requires more amount of water to excrete. Ammonia, ammonia, ammonia. Very good. Yes, yes, yes. Very nice. Exactly. Very good. You followed this. Very nice. Very good. Okay. Slow down. Okay. That's okay. Understood? So this is the basic concept of excretion. Once you come here, I will tell you more details in much elaborated manner. Okay. So we'll sign off at this point. We'll meet on Monday. Guys, okay? Shall we disperse for lunch? Okay, thank you.